Let's take a look at these two review problems concerning the definition of natural log x. First off, let's explain why if x is greater than 0, that y natural log x is equal to the integral from 1 to x dt over t. In a nutshell, this is the definition of natural log x. Natural log x is defined to be the value, so that if you take the curve 1 over x and you go from 1 to x, natural log x is actually defined to be the area under the curve between 1 and x. So whatever that area is equal to the natural log of x. Now it's somewhat surprising that this is equivalent to the usual definition that you think about, which is that natural log x is the inverse function of e to the x. But typically we take the area that you see here to be the definition of natural log x, and then we derive the properties of e to the x from this definition. So that's actually part A of the first part of the next problem. State the definition of natural log if z is a positive real number. It is the integral that you see here on the first line. Now, if z is complex, the story is completely different. So if z is complex, we write z is equal to r times e to the I theta, where we choose theta to be between negative pi and plus pi. So we have a number in the complex plane, z. Let's pick it down here for the sake of the picture. Then r would be the distance from the origin, 0, and theta is the angle from the positive real axis. When this happens, then we kind of define the log of z to be exactly what you think it should be. So just kind of using what we think to be the laws of logarithms, we define this to be the natural log of r plus I times theta. And that kind of follows what you would expect if the laws of logarithms were to hold true for an expression like this. Now this is equivalent to the definition at first, because if z is a positive real number, if z is on the positive real axis, then the angle is 0. Because it is on the positive real axis. And so the generalized log of z would just simply be the natural log of r, and r would be equal to z, the distance from the origin. So the new definition for complex numbers is completely equivalent to the definition for positive real numbers. So anyway, that's the definition of the logarithmic function under the two conditions, positive real number or else a complex number.